Hello everyone, or should I say good afternoon, because it's after 12 already. My name is Paulina Figol, and I'm a data analyst from IBM Client Innovation Center in the UK. So before I start talking about what blockchain is and what it really means to data science, I would like to ask you two simple questions. So the first one is, how many of you are familiar with blockchain? Pretty fair amount, I'm very impressed then. How many of you have ever heard of Bitcoin? Everyone, great. So the reason I asked for Bitcoin especially is because blockchain has started as a means of recording and verifying transactions. So it was a main factor of success of the digital currency of blockchain, of Bitcoin, sorry. Well, if it was success or not, that's pretty much a debatable question, pretty much for another discussion or presentation, I would say. But however, it has become a lot more than just a way to exchange money. So back some time ago when I was doing my master thesis, I was looking at the factors, the macroeconomic factors that influence the price of Bitcoin in China. And many of the researchers there, they underlined the concept of blockchain as a disruptive technology which is going to have an impact in the future. And I was thinking, yes, as a data analyst, then it's like a data warehouse, right? We're storing we're having the transactions, we're storing the data, and what do we do with this data after all? So you're probably wondering what this digital app is doing there. So how I'm going to proceed with the presentation is I'm going to tell you a story about physical and digital transactions, and after that I'm going to introduce, like, step by step the key concepts of blockchain. So if you imagine that we're in a park, sitting on a bench, there is me and one of you, and I would like to do a transaction with you. So I would like to give you an apple. So this is pretty straightforward, right? We're both there. We don't need any other third person sitting on a bench with us, and we just exchange it, right? But what if we wanted to do the same kind of things digitally, right? What if I wanted to send you the same apple, a digital apple, like online via some channels? We could also still pretty much do it via, for example, email or Facebook chat or WhatsApp, whichever channel, you name it. But on the other side, you might tell me, okay, you sent me the apple, but how do I know that this is the same digital apple? So how do I know that you haven't committed a fraud and put it online, for example, and enabled thousands or millions of people even to download it in the end? Well, that's a fair question, and I don't blame you for asking this. So what's the solution for this? Well, we could store this transaction, or we could record this transaction online somehow, for example, on a ledger. So this is another example from gaming industry, if you want. This is something what Blizzard has done, for example. So if we're talking about World of Warcraft, they had to record somehow the items that they've got. And this is where the next question arrives. So first of all, introducing Blizzard and introducing this kind of digital ledger is as if we introduce some third person to our transaction on the bench, right? So that's the first question. Second question is, what if the guys from Blizzard decided that, okay, I'm going to create another rare flaming sword and I'm going to put it on a ledger? He could do that, and because the ledger is owned by Blizzard. So, like one step forward after that, what we could do is to share the ledger between everyone. That would resolve the problem somehow, because everyone would be able to see the transactions and everyone would be able to see what was going on. And this is when the two first concepts of blockchain appeared. It's a business network and it's a shared ledger. Why it's a business network? Is because you can have n number of participants in blockchain. And then this is the kind of peer-to-peer or decentralized peer-to-peer architecture, because you share it among the nodes. So you share it among those business participants called nodes. Another concept is it's called smart contracts. And this is kind of interesting one because this is the kind of self-fulfilled contracts. So this is the rules of the game, if you want. And this is something that is pre-programmed in the programming language of blockchain. So those kind of transactions, when they are triggered, is self-fulfill. Next one is consensus. So to make sure that you've got exact copies of all of the transaction and to lower the risk of fraudulent activities, you have something called this is when I need to look at my notes once again. So yeah, to make sure that there are exact copies, you have digital signature. This is when the users, they verify the transaction. They said, yes, this is what we've done, this is what we want, and we all agree for the transactions. And the last one is privacy and confidentiality, which means that there are public and private keys to seal the record of the transactions, which are encrypted and hashed and and sent among the network. So what how IBM describes it as a decentralized ledger network, which means that every participant is kind of independent. It does independent transactions, but they're still connected somehow with each other because they're replicated in every single node. So to visualize a little bit how blockchain looks like and what is that all about with this cryptography after all, I put a picture from The Economists. So if you look at the transactions that we've got a transaction A, B, C, and D. And this is as an input that we put into blockchain. And then they are translated into an output in the form of unique hashed value of fixed length. So this is something that you've got in the top corner. And then what happens with these hashes, they're kind of connected, combined with each other in something called Merkle tree. And then they are sent to the header of the block. So what does the header of the block contain? This is, as I said, this is the hash, combined hash values, as well as some part of the code from the previous block. So this is why blockchain is such secure, because every single block contains part of the code from the previous block. So you can't change it. We don't have such computational power to change the blockchain because it's all connected to each other. So what is that with the cryptography? We also have the timestamp and something called nonce. So this is the header becomes a part of cryptographic puzzle, and this is solved by manipulating this number. And once the solution is found, a block is created. So one of the first questions that appeared to me since I work in consulting is, why would I invest in blockchain? Why would I change my reliable architecture into something like blockchain? So I derived 4 areas, so 4 differences between traditional database and blockchain. The first one is intermediation. And it simply means, this is something that I talked about just previously, that you have a record of all transactions, which is shared among the nodes, the market participants. And this is kind of, you have the smart contracts which make it self-fulfill. So this is kind of cheaper for organizations because you don't have to invest in architects, you don't have to invest in designing the processes, and it ends up cheaper. The other one is confidentiality, which is definitely something against blockchain, because this might be as a deal killer for some organizations. Blockchain is not for everyone, so this is probably the first thing that I should have said, and you will see that based on those characteristics. So in a traditional database, it is write and read controlled, while blockchain is only write controlled. So if you look at Bitcoin, for example, if you want to enter and start doing transactions, you need to create a wallet. So this is simple as that, and then you do the transactions. Everything is, after all, it's visible. Even though you do have those ID or customer IDs and this is hashed, then you still see the transactions. There are some steps to overcome this. For example, trading with several blockchain addresses or several business networks. And there are some other cryptographic solutions, but then they're still not going to be the same as a simple database when you can just restrict the transactions or restrict the data. Another one is robustness. So this is something also that I've mentioned before. Well, there are two types of, let's say, storing or data warehouses for blockchain. You can you can put it on every node on every computer, but you can also put it on several servers. So this is what makes it very robust after all, because if one node goes down or several nodes goes down, then it's still not a problem because the transactions are still recorded on other nodes, and then when they go live back after that, then they're synced automatically. You don't have to design the process, you don't have to configure, and you can add nodes whenever you want. And the fourth one is performance, which is still something bad for blockchain because it's never going to be as fast as a traditional database. So why do I think it's so important? This is because it started in 2008 seriously because it started from Bitcoin. But still, in 2015, the World Economic Forum has run a survey among IT specialists and data specialists, asking them how blockchain can impact. I know that it's not really visible, but I'm just going to read through for you. And they ask why blockchain is so important, and it turns out that 71% of respondents indicated tax collected by government via blockchain, that's by 2023. And by 2027, around 58% suggested that 10% of the global gross domestic product will be stored on blockchain. So yes, those are the two events. The World Economic Forum also regarded it as one of the 6 mega trends for the next decade, worldwide. Of course, this is not going to happen before the government and businesses kind of adjust to blockchain and adjust to the new technologies, to way of processing the data, to new taxation mechanisms, and then, yeah, this is still a process. So why don't we go into an application of blockchain, how this was applied and how this was used in one of the organizations. So the organization that I'm talking about is something called Decentralized Autonomous Organization, which means that this term comes from artificial intelligence, and it simply means that you do have the smart contracts, and smart contracts do the operation for yourself, so it limits the human interaction in those kind of businesses. So the first one was the original one with Bitcoin, for example. It should be cryptocurrency then as a category. So this is less loose. This concept is especially appealing for me because I'm an economist. So this perfectly illustrates the idea of sharing economy. And those guys who created less loose, they aim at limiting the traffic on roads, so in a way of using the unused vehicle space, so space in the cars. And what they said, they said that they needed at least 100,000 participants to make it work. And I think they, according to my last research, they reached that number in some of the US cities. And what they do is actually they're looking at social media and looking at not the sentiment, but looking at the similarities and dissimilarities between user, and they match it based on social media after all. So that generates a lot of data, right? That is kind of potential for data analysts. So I'd like to draw your attention to the last one, which is the collaboration. So the idea was to kind of provide an incentive for people to participate in this. They created also a cryptocurrency called Zeus. And the community collectively decides about the reward in Zeus for each contribution. So this is again the idea of consensus, that people agree on the concept, they agree on the transaction, and they collectively decide how much currency to transfer between the users. So what will be implication for analytics here? The first one is reactive to predictive transformation. Every time I think about this, I recall Uber. So I'm an Uber frequent user, and in my opinion, what Uber does is reactive analytics, and it's all because, for example, if you do have high traffic on the road, then it turns out that the price of the ride is increasing. So sometimes it's even 4 times as high. Every time I need to reject them. And then, so the reason why is that reactive to predictive, because what you can do with this information from Zeus is you can actually do some predictive analysis. So if there is a traffic or high traffic, what you can do to prevent it, or what you can do to increase the number of cars, or to solve that problem somehow. And this is what smart contracts would help with, because they're self-fulfilled operations, and they might provide like a facility, or like the way of facilitating big data and facilitating the transformation between reactive to predictive analysis. What about the last two? It's consensus data and smart data. So consensus data, well, as we said, the first two keynote speakers said that around 80 or 90% of data analyst time is spent of cleaning the data and the data quality issues. So with consensus data, I think, and smart data as well, we can solve this problem to some extent, because the consensus data are trusted data. So this is something that the participants agreed on previously, and we can continue, and we have like a stable set of data and trusted data after all. In terms of smart data, this is also a new concept in fintech. And smart data is again quality data as a subset of big data, if you want to name it, is without the noises. They're kind of structured. So I think blockchain could also provide this kind of structured, trusted, and stable data for data analysts, and that would, as I said, that would limit the data quality issues. So what are the limitations? If you are looking at Zeus, for example, when I was doing a deep research about this, and I found that initially they stored the data on a server, a couple of servers, and then they were moving gradually into blockchain, and they said that they're going to store, again, they're going to have a couple of servers, and they're going to store all this data on the servers. But on the other side, they said that transaction will be only seen between the market participants. So even then, they're not going to have the access to all the transactions. And this is, I think, a threat for data analysts and data scientists, because if it turns out that blockchain cannot process those data, well, it processes its data, but it's not visible for us, then how are we going to process this, and how are we going to analyze those kind of data? So this is a threat. And if more companies are using blockchain, and if more companies are using it and hiding the data, then it's going to be even like a bigger problem after all. There are other limitations. For example, a limitation of throughput to 7 transactions per second. If you compare it to Visa, Visa processes around 2,000 transactions per second with an upper limit of 10,000. And blockchain is just in average is 1 transaction, and an upper limit is 7 transactions. What can we do to overcome this problem? Well, we could, for example, extend the size of the blocks. But this is again something challenging because the data in a traditional database can be compressed, but you can't compress this type of data on blockchain. This is again an opportunity for developers to develop an algorithm for compressing data. So we probably need to ask the guys from the Silicon Valley if you're familiar with this series. And the last one is the countering vulnerability to 51% mining attacks. So in here, how it works in Bitcoin, for example, is you have miners who process those algorithms and dig the currency or mine the cryptocurrency. And then there is a very limited amount of those miners. So if it turns out that someone owns more than 51% of the network, then it turns out that you can easily manipulate with blockchain, and this is something to be overcome, pretty much. So what's the solution? There are some companies who are developing blockchain, and one of them is something called BigchainDB. So it combines it combines Bitcoin blockchain and the distributed database. So what they do is, I think they can process 1 petabyte of data, and they can process up to 1 million transactions per second. So this is the extent to which you can develop blockchain after all. So this is the immutability, no central authority, and asset over network of blockchain, and the throughput, latency, and capacity from a distributed database. So you can look at blockchain as an opportunity and as a threat at the same time. But you can see that this is pretty much disruptive innovation. So this is something at which the governments are looking for to implement, because, well, as I said before, if you don't care about well, on the other side, if trust and stability or data redundancy is not an issue, blockchain cannot do anything else except that. And this is, I think this also includes the idea of the smart contracts to some extent, because I could risk and say, okay, so, well, SQL can do the same. You can retrieve the data, you can do whatever you want. But on the other side, SQL, you need a human interaction. So this is something that is missing here. And as I said, this is again, anonymity and security. Security because of data redundancy, because the data is actually replicated everywhere and it stays in sync after all. And then it's still anonymous because all the transactions are kind of encrypted and it's presented as a hash. So you don't really see. So if you look at Bitcoin, for example, and Bitcoin blockchain, there is a website which you can look at, and you can look at the transactions there. You can see where the transaction was done on a map. You can see the hash value, but you can't really look at the user. You don't know who the user is. And as I said, it's opportunities and threats at the same time for data analysts and data scientists. So as I said, I started from questions, and probably will finish with question to you. If there is anything more that I missed, and there is any impact on other areas for analytics. Thank you very much.